We're going to look at one more example similar to the first two that we looked at in this section. Here I'd like to sketch the graph of g with all of these characteristics. So first I'm told that the domain is all real x. This means that we're not going to have any vertical asymptotes. I shouldn't expect to see any in this particular problem. We're given a few ordered pairs here. We have -2, 1, so let's actually just go ahead and plot that. -2, +1, we've got a point right here. We've got a point at 0, 0, so we have a point right here. And a point at 2, +1, we're going to have a point right here. So those are the three ordered pairs that were given. We're also given some information about the first derivative. So let's create a sign chart for our first derivative. Here I'd like to talk about g prime, and let's see, g prime of 0 is equal to 0, so that means that 0 is going to be a pretty big deal here. And it looks like we're changing sign for our first derivative at 0. It looks like that's going to be the only critical point that we have. So I'm told, first of all, that g prime of 0, remember this guy right here, this is really an x value. That's what this represents. So I'm told that g prime of 0 is equal to 0. This is saying that the derivative of our function is 0 at x equals 0. So I'm going to put a little 0 right above there. And what that tells me is whatever my function looks like, I should have a horizontal tangent line at x equals 0. So let's see. G prime of x is less than 0 on -∞ to 0. So on -∞ to 0, that's the left-hand interval over here, our first derivative is less than 0. Our first derivative is negative. So our function must be decreasing on that interval. And then on 0 to +∞, so this is talking about the right-hand interval, we have g prime of x is greater than 0. That's another way to say that the first derivative is positive, so our function must be increasing there. So we can kind of look at this and see, okay, we're decreasing and then increasing. Right there at 0, we have this horizontal tangent line. Whoops. We have that horizontal tangent line at 0. This 0 right here should be a minimum. And if you need to, go ahead and label that in your graph. Go ahead and make a note to yourself and say, you know what, I know that that's going to be a minimum for our graph. And actually, I'm going to go one step further. I'm going to sketch in that horizontal tangent line at 0, 0, just so that when we come to graphing it, I'll remember that it's there. So that's everything that the first derivative is telling me. Then they give me some information about the second derivative as well. So it looks like the second derivative, they're giving us all sorts of information. They say g double prime of -2 is equal to 0, and g double prime of +2 is equal to 0. So here's g double prime. The x values that seem important so far are -2 and +2. And if I look at where my second derivative is changing sign, it's changing sign at -2, -2, +2. Actually, you know what? I have a typo in this problem too. I must have, this is +2. That's my fault. That should be a +2. But it looks like we're changing signs at -2 and +2. So this guy up here, this is telling me that the value of the derivative at -2 and +2 is 0. So I'm going to make a note to myself that the value of the second derivative is 0 there. What else do we know? Let's see. If I look at that second point right here, here on the outside interval, so -∞ to -2 and +2 to +∞, g prime of x is less than 0. So g double prime of x. G double prime of x is negative on the two outside intervals, so our function is concave down on those two intervals. G double prime of x is greater than 0 in between -2 and +2, so g double prime must be positive in between. So we see that concave upward shape. And hopefully that should look pretty familiar, like, hey, we see hopefully that local minimum that we're going to have at x equals 0. We see that reflected in our concave upward graph. This last piece of information, this might be a little bit tricky. We're told, and actually let me erase this. We're told that the limit as x approaches negative infinity, so as I move as far to the left as I possibly can on my graph, my function is going to approach positive 2. Same behavior on the right-hand side. The limit as x approaches positive infinity of g of x is equal to positive 2. And what that means is these two together really mean that I have a horizontal asymptote at y equals 2. So that means as I approach negative infinity and positive infinity, if I look at the left and right hand end behavior, we're going to get closer and closer to that dashed horizontal line that I've drawn in there. At this point, I think we've got enough information to sketch the graph of our function. One other thing that I didn't make a note of, and I'm going to do that now, look right here at negative 2 and positive 2. Notice that we're changing concavity. Here we change from negative to positive, and over here we change from positive to negative, which means that these are both inflection points. This is an inflection point, and this is an inflection point. So again, I'm going to just make a note to myself that these are inflection points. Those are where we change concavity. So let's look at this middle section, I think, right here. I think that's probably where I would start. Here, if I look at this middle section, my graph should be concave upward. And some of this we've already talked about. We said that there is a local minimum. We said that this was a minimum at 0. And we have this horizontal tangent line that we've already sketched in. So I think at this point we should be able to talk about that middle part quite a bit here. It's concave upward. There's my minimum. Oops. Let's try from this side. Concave upward. There's my minimum with a horizontal tangent line. It looks something like this in between negative 2 and positive 2. The outside edges might be a little bit trickier to handle. Let's start over here on the left-hand side of our function. If we look at the left end behavior, there we said our graph was concave down, so our graph is concave down. I always like to draw that. Oops, concave downward. And if I think about what my function is doing there, it's decreasing. So it's decreasing. It should look something like this. So okay, maybe we'll erase that left-hand side because we don't want to be distracted by it. But this is fairly steep. We can't quite use that because then you're going to cross the horizontal asymptote. And while I suppose you could here, I'm gonna say that we don't cross the horizontal asymptote here just to keep it simple. So here we might just need to flatten that out. We might need to flatten that out so that we have our function still approaching that asymptote and not crossing it. So we should see something that looks like this. And we should be able to check as we move from left to right, is our function decreasing? Well, yes it is. Is it concave downward? That one might be a little bit harder to tell, but yes, our graph is concave downward there. We should see some similar behavior on the right-hand side as well. So over there, we said our function was concave down. So okay, let's draw the function which is concave down. And our first derivative tells us we are increasing there. So this is the part that is concave down and increasing. If we erase this right-hand side, again, it can't be that steep because we would cross the horizontal asymptote, so we might need to kind of squish it down a little bit and kind of compress it a little bit so that it's just a little bit flatter of a shape, and we should see something that looks like this. And hopefully if we look at this, we can sort of see, especially right here, this limit statement right here, that horizontal asymptote. As we approach negative infinity, we're approaching that dashed horizontal line at 2. And as we approach positive infinity over here on the right-hand side, again, we're approaching that dashed horizontal line at positive 2. So that's it. That that right there is my function. I have everything I need. Again, I think that these are really good questions to study. I can promise you I will ask you at least one, maybe two of these on the exam. So make sure that this is something that you spend some time with, because I do plan on asking a couple of these questions.